In this video, we're going to be finding the equation of the parabola if we're given the sketch, right? There are three ways that we're going to discuss on how to find the equation of the parabola when we're given a sketch, right? The first thing you look for on the sketch is what you are given. In this case, I am given the x-intercept and the turning point and the y-intercept, right? Perfect. Always, when you are given the x-intercept, you have to use the form that is called the x-intercept form, which is y equals to a, open bracket, x minus x1, close, open, x minus x2. This formula, you should know it off by heart. It's not going to be given to you in the exam. You need to know the x-intercept form of the parabola. Okay, perfect. And then on this formula, right, this will be your first x-intercept, which is x1. Then this will be your x2, your second x-intercept. Okay, so you always firstly substitute your intercepts. So let's substitute our intercepts. So I have a. Here I'm going to have x minus, and then I substitute the -1. Then I close this one, right? Then I have x minus, and then I have to substitute the second one, which is 4. Then I close this one, and then I close the main one, right? Then this becomes y equals to a x. This 2 will be a plus, negative, and negative. So I have +1 there. Then I have x. Here it will just be -4. Right. And then I advise you to do this here. No? You're gonna do this here, and then but here let's do something first. So here we're going to have y equals to a, right? And then we're going to FOIL here. And x times x, it's x squared. X times -4 is -4x. And then this times that will be plus 1x. Then this times that will be -4. Right. Then this simplifies to a x squared minus 3x minus 4. Right. So we're almost done. We only left with one unknown, which is a. Ne? So let's go back to that arrow there. So on the arrow here, ne, after you substitute your x-intercept, you need to substitute any random point that lies on the graph. Any point that lies on the graph except these two, because these two you already used them. You can't substitute any of those. So the only unused point in this case is this one. Remember, this is your x, that's your y, right? So where I see x, I'm going to put this. Where I see y, I'm going to put that. Sharp. So my y is here, which is 2, equals to a. And then I substitute 0, which is x. And then 0 plus 1. I just did vice versa there. Do we see it? And then let's see what we're going to have here. Ne? Okay, let's do this. So we have 2 equals to a minus 4. And then that one will be 1, right? Then we have 2 equals to a times -4. It's -4a times 1, which is still -4a, right? And then you want to isolate the a, so you divide by -4 on both sides. So you have -½ equals to a, right? And then now you come with your a, you put it in here. So you have y equals to -½ x squared minus 3x minus 4. Then you FOIL in the -½. So you have y equals to -1/2 x squared. This times that will give you +3/2x, right? Then this and that will give you +2. And that's finito. You've got your function. I'm sure you are realizing that it's easy. The only thing you need to know is this formula, né? The x-intercept form, because there's no any other way you're going to get this if you don't know the x-intercept form. It will just be a complex mess, né? So go learn that formula. So far, parabola has 3 equations. We have learned about the basic form, the turning point form. Now we have the x-intercept form. You need to know all those 3 versions of a parabola. Okay, let's do the second example. Okay, second example. Okay, I just wrote the equations to save time, basically, right? So here, I'm given x-intercepts. So I know I'm going to use the x-intercept form, right? Sometimes here they can say this, ne, to try to confuse you. They can say f of x equals to y equals to z. Ne? That just means that y equals to z, or f of x, which is also y equals to z. Ne? Sharp. Then we have a point there. Perfect. So I'm sure you can see that this is still the x-intercept form. So this will be x1, and then this will be x2, right? So let's substitute. We have y equals to a. I'm sure you can see it's going to be x minus 1. Then it's going to be x minus 5. So the minus signs don't change because you have all positive values here. So no need for brackets, right? Then remember, you make a small arrow here that you're going to use later. Then you come here, you have y equals to a. You need to FOIL, né? This times that, x squared. This times that is minus 5x. And then that minus 5x is going to be like term with this one. Negative 1 times x is negative x. So here in total, when you simplify, you're going to have negative 6x. Then this one and the last one will give you plus 5. Ne? Perfect. Now let's come here. Remember here, you take a point. This is your x. That's your y, right? So my y is 12. Equals to a negative 1 minus 1 negative what? I mean positive 12 and then minus 5, right? And then let's see what does this give us. Let me just check if I substituted properly, right? So y is 12. Then we have that. Okay, this one here is not correct, ne? Something was not seeming okay. So yeah. So that one there, it's minus 1. It's the x, is this one, ne? It's minus 1. Sharp. So we have 12 equals to a minus 2, then minus 6, which is 12 equals to negative 2 times negative 6 is positive 12 times a is 12a. Then we need to isolate a, so it means we must divide by 12 both sides. Therefore, a equals to 1. Then you take your a, you substitute there, which is 1. So you have y equals to 1 x squared minus 6x plus 5, right? Then which is y equals to, if you multiply by 1, the bracket won't change, right? Because 1 doesn't change anything when you multiply it with that thing. And that's your function for this one, right? Sure you saw that this was also easy. You just need to know the x-intercept form and know how to substitute and just know how to do basic multiplication of brackets and all that. Né? If you found this video really helpful, likewise, don't forget to hit the subscription button and to share with family and friends. Thank you very much. See you in our next episode of Maths Fanatics 24/7. Thank you.